Hello friends, thank you for watching this video. I am Mohamad and today we'll be continuing our journey exploring Azure. On this episode, we will explore and dig deep into the theory of Azure Functions. So, what are we going to be covering today? We're going to be discussing serverless cloud computing, then we're going to be discussing the difference between traditional and serverless computing, then we're going to understand Azure Functions, why do we need it, then we're going to be digging deep into different aspects of Azure Functions like bindings and triggers and so on and so forth. Then we're going to be discussing how can we build Azure Functions. As always, please comment your questions and clarification and suggestions in the comments down below. Please like, share and subscribe if you like this video. It will really help the channel. So let's get started. So first, serverless computing. What is it? Serverless computing hosts and runs code on the cloud. It is serverless in the sense that we don't need to install or maintain service to run our code, which means no infrastructure headaches. The infrastructure is already set up and it's already configured for us to utilize. Serverless computing eliminates this infrastructure barrier for developers and anyone who is trying to directly get up and ready to develop. As well, it will provide a very strong, powerful infrastructure tool that we can just directly get out of the box. As well, it will eliminate all of the complexity of us managing servers and configuring them. So, what is the difference between traditional deployment and serverless deployment? We'll start by traditional deployment. So as we can see here, in order for us to deploy our website or for example, our application that we want to create on a normal server, what we need to do first we need to get the server and we need to decide what type of server is it, if it's going to be a Windows, it's going to be Linux. And then once that's done, we need to actually do all of the configuration. So step 2 is actually configuring that service, configuring IIS, for example, configuring the right directories, configuring the securities, and all of those. And then we need to install certain admin privileges, so on and so forth. Once that configuration is done, the next step is usually for us to actually deploy our code. And that, for example, if we're deploying our code, it could take different ways for us to do it. So for example, it could be just downloading a copy of the exported source code and running it from there, or we can actually set up like an infrastructure build where we can actually directly download the latest source code through DevOps and we can actually have it there. So it could be a complete different process. And lastly, it's basically securing the code, so securing the server, so setting up all of the firewalls, setting up all of the right access rights, closing all of the ports that we don't really need, deciding the right read and write for our application, and so on and so forth. So usually the traditional deployment can take a minimum of these 4 steps, but there are so much more steps that we can add, but these are the bare minimum that we need to do. But that's not all. Once we actually finish deploying and the application is running, there's a lot more work that needs to be done. And basically the maintaining of the servers and keeping them running and make sure that there is no fault and make sure that they have high availability, it's a complete job by itself, because maintaining its servers, maintaining all of the infrastructures can take a lot of time. So what are the tasks that we might need to do after actually deploying? So it could be server management, making sure the server is healthy, making sure that it has all of the right resources are available to it, we have enough space, make sure the security is up to date, downloading the latest patches and latest fixes to our server operating system, and so on and so forth. Second, it could basically security monitoring. We need to make sure that all of the ports are running as it should be, all of the security stuff are actually working as it should be. We don't have any malicious software that has been uploaded into our server. We need to make sure that all of the right privileges are set in place, and so on and so forth. So security monitoring is another step. And then, as we said, keeping the server up to date with the latest batches and fixes for the operating system as well as for the application itself. And then we need to resolve any configuration issue that might arise. So for example, let's say we are connecting to different services, that we need to make sure that there is no any configuration issue when it comes to that. As well, in order for us to keep all of those running smoothly, we need to have some experience in running different types of servers. So for example, if we're utilizing Windows Server 2016 and we need to upgrade, for example, to Windows Server 2019, we need to understand what's the might break, what's gonna work, is there anything that we need to change. We need to understand the fundamentals of the servers and how do they work. Even if we're using Linux, if we're upgrading, for example, from Ubuntu 18.1 LTS to 20.1 LTS, also needs to understand understand what's the changes, how it's going to affect our application, so on and so forth. As well, there's going to be multiple type of server that we need to maintain. So it's not going to be only one server. It could be, for example, load balancer that we need to take into consideration. We could have a physical firewall that we have installed as well. For example, we might have a different database server. So all of those fall into the same umbrella. As well, one of the most important thing is scaling of our application, because currently once we have installed our application on a single server, that application is going to live there, and whatever the server resources does it have, this is the only this is how much we can expand and scale our application. So let's say our server will have like 16 gigs of RAM and 250 gigabits of storage. That's the limit it's gonna reach when that server actually hits that limit. So if we're gonna scale it, it's gonna be a much more complicated item. So if we need to set up a new server, we need to configure the load balancer all over again. We need to set up a different connection routing. We need to set up stuff for the caching if we're utilizing it. We need to set up stuff for authentication of the users. So it's gonna get more complicated as we scale up the application. So with traditional deployment, as we saw, there's a lot of stuff that needs to be taken in order for us to keep our application healthy and running smoothly. But with serverless computing, there's a lot of these stuff that we can actually remove and just focus on the actual code itself. So let's explore that. So when it comes to serverless computing, all we need to do is basically two things. First, get access, which means actually creating an account on a serverless platform or on a cloud platform like Azure, AWS, Google Cloud, so on and so forth, and create a application there, which is basically the serverless computing, or for example, in our case in Azure, it's going to be Azure Function. And the second step is usually just deploying our code, and whatever configuration we have implemented in our code, it will be automatically implemented on the cloud. So as we can see here, we went down from at least 4 steps to 2 steps, and basically one of the steps is just creating an account, which is, as we can see already, it's way more easier and way more flexible. Once we deploy our code, what do we need to do now? As we can see here, we don't have any server management, we don't have any security concerns, we don't really need to worry about auto scaling, we don't really need to worry about configuration restrictions, we don't really need to worry about making sure that the server is up to date and all of the firewall settings, because all of that is being taken care of by the cloud provider, and all of that are being handled by them. So for us, all we need to worry of is making sure that our code is running as it should be and more efficiently as it should be. So we can see here that the level of abstraction that serverless cloud computing provide us is really key here in order for us to have our application running as smooth as possible, as fast as possible, and deploy it as fast as possible as well. So after we have went through this introduction about what's the difference between serverless and traditional deployment and traditional computing, we're gonna now jump deep into Azure Function and understand how do they fit in within all of that. So what are Azure Functions? So basically, Azure Functions is the ability to write code without setting up infrastructures, no servers, no virtual machine, no containers, no nothing. Azure Functions are quick to build and easy to maintain and powerful to operate. They are easy serverless functions that can scale automatically to meet demands without to worry about infrastructure provisioner or any servers. So basically, it takes the serverless computing that we have discussed before, and it's the Microsoft implementation on Azure. So basically, Azure Functions give us the ability to write our source code and directly deploy it without worrying about anything related to infrastructure, because Azure is going to handle all of those for us, and it will allow us to have scalability from out of the box directly. So let's say we have 1,000 users using our service, and all of a sudden we have a flood of users, like it went from 1,000 to 50,000. Azure Function will automatically scale up our service in order to meet the demand, and then once that demand go back down, it will automatically scale back down. So all of that work is automatically handled by the cloud. We don't have to worry about anything. So why do we need it? First, Azure Functions have provided us the benefit of PaaS, which is basically platform as a service, as well as infrastructure as a service in a single platform. Azure Function, as we said, is a serverless solution that allows us to write less code, maintain less infrastructure, and save us a lot of cost. So instead of worrying about deployment and maintaining those servers, the cloud infrastructure provides us all up-to-date resources that we need in order for us to keep our application running. They are small bits of pieces of code which can only run a single functionality we are providing. We can make it more complicated and we can write multiple functionality inside our Azure functions, but that's not the benefit of it. So basically, Azure function, the idea of it, we need to trim down the functionality to a single functionality and have multiple Azure functions running together in order for us to complete a single functionality. So for example, we trim down to a single functionality, then we connect this function to another function which does another functionality, which connect to a third functionality, third function what does a different functionality, and all of these works together in order for us to provide, in order for them to provide the best outcome and the best performance that we might have. So as we said, they are small pieces of code which only care about the functionality. And basically, how do we interact with these Azure functions? Basically, we interact with them through something called triggers, and we're going to be delving more deep into what are triggers in later section. But just like a quick overview, triggers is like it could be like a web call, it could be like a queue calling it could be different stuff, but we're going to be delving into more deep what are the triggers and how we can utilize them within an Azure function. So let's see the benefits that Azure Functions provides. So the first benefit is the variety of language that it supports. So out of the box, Azure Functions has support for many different languages, from C# to Java to F# to Node.js, PHP, Python, and more. So these tools are out of the box supported by Azure Functions, and we can see that there's a lot of potential because we can utilize any language that we want and any framework that we want, and we can actually deploy to Azure function with peace of mind, and it will be supported out of the box. So the second point is integration. Integration it means that we can integrate with different Azure services directly out of the box when it comes to Azure services, because Azure Functions is already part of the Azure family, and we can actually set up the network ruling where it automatically connect with with other Azure servers on the same network. So that way we are directly integrating with different Azure services without having to worry about the infrastructure and how they are able to connect to each other. The next point of why do we need it is the pay-as-you-go model. So basically, when we're not using the function, we're not being charged for it. On a traditional sense, when we're having a server and we have it set up and our application is hosted on it, even if our application is not being in use, and even if it's like being idle for the last month, we still have to pay for the resources because they are allocated to us, and we cannot really get away with not paying because we are allocating these resources. Whether we are using it or not, it's not the problem of the hosting company, because we are basically renting these resources, and we have to pay for them no matter what. But with the pay-as-you-go model, basically it means that we only pay what we use. So for example, let's say our application, our service runs for like, for example, 5 seconds. We only pay for these 5 seconds that it's running. If it's running, for example, an hour a day with different calls, we only pay for that hour a day. So here you can see that the power that comes from saving cost, because basically the more we use it, for example, the more we pay for it, and the less we use it, we don't have to pay for these. And here we can see that when it comes to scalability, we can see how it's much more affordable than having as well traditional servers and traditional infrastructure, where it's going to save us cost on the short run and as well on the long run. The next point is automatic scaling, and basically automatic scaling, it means that, as we said before, if we need a lot of resources, like our users base jumped from 1,000 to 50,000, Azure will automatically handle the scaling for us. No need for us to do anything from our side. Azure is going to be handling all of the scaling and infrastructure and setting up all of these new machines for us without even us knowing what's going on. And once that traffic has gone, Azure will automatically be responsible for removing all of these extra servers that has been allocated and scaling it back to the bare minimum that the function need in order for it to run. Our next point is reliability. Since it's going to be based on a cloud provider, which is Azure in our case, we're going to know 100% that it's going to be reliable, because the infrastructure and the server management and all of those resources are basically handled by Azure. And in case something went wrong, Azure will automatically pop up a new a new instance of our function, and it will make it run for us. So we don't really have to worry about reliability. And lastly, flexibility as well. Flexibility, it means that we can actually make a single call run from 1 second up to 10 minutes, and we can even extend it way more with more premium plans, as well as the ability to integrate and actually utilize a lot of the services out of the box. That's where the flexibility and the power comes for Azure Functions. So now that we have covered an introduction about what are they in theory and basically what are the benefits, now let's dig deep into some of the characteristics of an Azure function, and let's understand how everything fits together. Because once you're starting into this field, you're gonna hear a lot of stuff about triggers, binding, monitoring, runtime host, and all of these. So right now we're gonna dig deep and we're gonna explain every single one of these in details. So the first thing is naming. So with Azure Functions, you might have heard of Azure Functions, Function App, and Functions. So what's the difference between them, and why do we have all of these? So when we start working with Azure Function, we're gonna encounter a lot of the function keyword all over. And as a beginner or someone who's trying to understand it for the first time, it could be a little bit confusing. So let's break down the different terminology. So first of all, Azure Functions, what are they? Azure Functions basically here stands for the name of the service itself. Like for example, we have Azure Virtual Machines, Azure Blob Storage, Azure AI, Azure Blockchain, so on and so forth. Azure Function is another service that Azure provide. So as we can see here from the first big circle here, everything that we do is basically inside the Azure platform. And basically Azure Function here stands for the service that Azure provide. The second one is Function App. Function App is basically an instance of the Azure function that we are currently utilizing. So once we want to create our own Azure functions, what we do is we create a function app, and that's the name of it. So it's an instance of Azure functions for us. So that's our function app. So basically, for example, a single function app, our single Azure function can have multiple function apps, but for now we're only showing one. And the function app, as we said, is an instance of the Azure function. So what are functions? Functions basically are the pure code that we have written. And basically inside a single function app, we can have multiple Azure functions running at the same time. So as we can see here, we have one function here, another function there, and so on and so forth. So we have here, in this example, we have 5 functions, and these 5 functions all fall under the same umbrella of the same function apps. So let's explain this a bit in more detail. So let's say, for example, I want to create the upload of a file functionality within Azure Functions. And I want to create, for example, a single functionality, one for handling the upload, another functionality to handle the resizing, another functionality is to handle the naming, for example, and another one to handle the updating of the path. So how can I do that inside a single function app? So the first function basically here, it will be responsible of detecting if there is any file upload and basically notifying the other functions that, okay, something has happened and we want to do something with the file that has been uploaded. So the second function will be basically responsible for taking the file that has been uploaded and resizing it. The third function will be responsible for example, update the path of that file that has been uploaded. So once we have, for example, called the first function or triggered the first function, the second function will trigger the second one, and the second one will trigger the third one, and so on and so forth. We can have them like that, or we can have them completely independent functions that don't even know about each other. So the flexibility here is really big. But going back to naming, so Azure Functions is a service that we utilize from Azure in order for us to create our serverless application. Function app is an instance of those Azure functions, and function itself is the actual source code that we create in order for us to upload. It's the source code itself that we have to create and we upload to the function app in order for us to have our code running on the cloud platform itself, which is on Azure. So Azure Functions is a service, function app is an instance of that service, and the function is the actual source code that we upload to the function app. Great. So the next point that we want to discuss after this is basically triggers. And Azure Function is event driven. So basically what that means that this attribute refers to the code being executed when the Azure function starts. So everything within Azure Function is, or every time an Azure Function starts, it is being triggered by a certain event. And to trigger an event, there is a lot of way we can do those. So Azure Function supports a list of a really long triggers event, but for now we're gonna be focusing on 3 just for the sake of this demo. But I will add a link in the description down below where you can actually see the list of all of the triggers that Azure Function supports, and you can actually implement any one of those depending on the use cases that you need. But for simplicity's sake, these are, I think, the most popular ones, and we're going to be explaining them in details. So as we said, Azure Functions are event driven, which means that they respond to an event, and basically they don't run by itself. They must have certain actions that initialize them. So the first one is going to be HTTP trigger, which basically means as if we are calling an API request. It's the same way we call an API. It's the same way that we call an Azure function within HTTP trigger. So it should be a URL, and we call that URL. And once that URL is being triggered, the Azure function will run. So here, for example, we can see we have a client, and once that client, when we're doing anything on our application, for example, uploading or generating an Excel file, as soon as we want to generate that Excel file, we call this Azure function, and Azure function through an HTTP trigger will actually start running, and it will execute itself. So basically, it's a very simple process. It's basically an API we are trying to call. We think of an Azure function and HTTP trigger is like an API endpoint that we are trying to call. The second one is blob storage. So let's say we uploaded a file into our blob account, into our blob storage account, and basically what we need to do is once that image is being uploaded to that blob storage, what we want to do is resize it. So instead of having different types of call and doing another call to the Azure function through a HTTP trigger telling it, okay, that we have uploaded this file and you need to resize it, the nice trigger here is that as soon as we upload a file into the blob storage will automatically call the Azure function for us. This is oversimplifying, but that's the gist of it. So basically the blob storage will automatically trigger an Azure function because they will all be listening in, and if there's any action coming from our own blob storage. And once that file is there, the function will do its work without even us triggering it, because basically the blob storage took that responsibility for us and actually triggered that Azure function. And the third point that we want to discuss here is timer. So let's say I have some kind of a task to clean up my database, and it needs to run once a day. Every 12 hours it needs to run that cleaning up function. It's very simple. So I can set a timer on my Azure function, and I can actually utilize the cron logic for it. So I can specify even the days, minutes, hours, seconds, even milliseconds. And from that point forward, whenever that timer is triggered, it will automatically trigger the Azure function to work. So for example, as we said before, if I have, for example, to run once a day every 12 hours, I can set my timer for every 12 hours. And as soon as timer mature, it will automatically trigger the Azure function to run. And then once that Azure function is finished its work, it will sit on idle until that timer is hit again. It will run all over again. So these are the most popular one. But again, there's way many more triggers that you can actually utilize in order for you to integrate with an Azure function. So the next point is going to be bindings. What are bindings? So Azure Functions is a service that consists of various functions, as we said before in the example of uploading an image. And for example, as we said before, if we want to upload an image and it has a lot of stuff that needs to be doing, like resizing, updating the path, so on and so forth. So Azure Functions is a service that consists of various functions. And when we're running a function to connect to other Azure services, to do that, we need an binding. So let's say we have uploaded a file, and that file, after that has been uploaded and we resized it, we need to save that resized image back into the blob storage, and then we need to update the records in our database telling it that this is the new path. So we're going to utilize, for example, a NoSQL database, Azure Cosmos, and then we need to add the logs so we can actually process and to see if everything is run correctly. We need to communicate with Kafka So all of these services require the Azure Functions in order for it to communicate with them. It requires something called bindings, and basically bindings is, we can think of them as links or like bridges that Azure Function utilize in order for it to communicate with other services. So those services are bidirectional, so it's in and out, so we can actually send stuff to them and we can receive stuff from them as well. So bindings refers to the way our Azure function is linked to those Azure services, and how the information are being transmitted from our Azure function to those services itself. So let's take, for example, the first one, which is going to be our Kafka one. So basically Kafka is always responsible for, or mostly used for, operational services or monitoring. So we monitor the data that's coming in, we monitor the logs and aggregating statistics and so on and so forth. So anything that we want, or any logs that we want to save from our Azure function, we can directly put it into Kafka. And as we said, again, for Cosmos storage, if we're trying to update the records that we have created into the Cosmos storage, we can actually directly communicate from there. And if we want to save the output of the Azure function into a different blob storage, we can actually utilize blob storage bindings in order for us to save it there. So it's a very intuitive way, and it's a very powerful way in order for us to leverage the power of Azure and different services that is provided for us out of the box, without us to worry about, how are we going to communicate with this, what's the networking rule, what is the infrastructure that we need to communicate. All of this Azure function with the bindings, it's a very powerful thing that we can utilize. Next, we're going to be discussing monitoring and runtime host. So one of the most powerful things about Azure Functions is it comes built in with application insights. And if you don't know what application insight is, it's basically a tool that is integrated within our usually web application, and its main job is for it to gather data that the application generates. And this data can be traces of an app, crashes, logs, so on and so forth. And it will give us a really nice dashboard where we can actually delve deep into that data, and we can understand if something is going wrong. We can understand the errors that's coming out with the status code, and if we enable stack trace, we can see them all of there. So application insights is automatically we need to enable it, but it's out of the box compatible with Azure Functions, and this will allow us to actually understand what's going on in the background within an Azure function when it's running, and it's actually allow us to see how it's performing, if there's any optimization that we need to be done, or if there's any error or breaking stuff that's happening. We can actually directly understand it from the application insights. Next, we're going to be discussing the runtime host. And what is runtime host, you might ask. So let us step a bit back. And as we said, Azure Function supports different languages: C#, Java, PHP, Node.js, so on and so forth. And as we know, these languages have different versions as well. So when we upload our code to Azure, we need to tell it, or we need to configure it or inform Azure and the Azure function but what are actually the languages that we're using and what versions that we are currently using. So the code that we write inside our Azure functions needs to be known to Azure. So Azure will be able to run that compile code. But the way we communicate these information to Azure is usually with runtime host. So every function that we create must have a runtime host. And basically a runtime host is like a file inside our Azure function, and that runtime host determines the language and the version that we are currently using for our function. As well, it supports Azure function currently support 3 different versions of runtime host. Because we have 3 different versions of Azure function, because it has progressed over time, we have version 1.x, 2.x, 3.x. All of them are still being supported, but Microsoft really encourages us to utilize version 3.x and forward. So runtime hosts have 3 different versions, which is 1, 2, and 3. And for example, whenever we create any new function, the runtime host will automatically be built based on the specification of that function. So if we chose C#, it will be C# with the language of C# that we have created. But again, it's really recommended for us to utilize the latest version, which is 3.x, because it has the latest and greatest functionality and latest bug fixes, so on and so forth. So as a summary, runtime host is basically the way that we inform Azure of what type of language we're using and what version of that language we're actually utilizing. So let's do a quick dig deep summary. So basically, first of all, we have discussed the naming, what's the difference between Azure function, function app, and a function. And then we have the triggers and the bindings. So the triggers are basically the stuff that the events that initiate the Azure functions, and the bindings are the outcome that we can actually add to our function to make it more beneficial for us, and we can leverage the power of the cloud. So as we can see here, the triggers can be, as we mentioned before, HTTP request, timer, and Azure Blob Storage, which there's a lot more. And the bindings can be Kafka, Cosmos DB, and Azure Service Bus, Azure Blob Storage, and so much more. So basically, it's the triggers are the way we initiate Azure functions, and bindings the way we initiate either other Azure function or other services that we might utilize through the power of Azure functions. Now, let's discuss hosting plan, which is basically one of the most important things when making a decision. Other than the technicality is the cost, because cost really matters when it comes to production and having a real live application online. So even though we don't have to manage the servers and the running code of the functions, we must still have tell Azure a little bit about our Azure function itself. So Azure Functions infrastructure is divided into hosting plans, and basically there is still hosting plans. So even though we are not creating the server, or we are not configuring the infrastructure, or we are actually specifying the network rules and all of those, but we still need to choose 3 different types of how our function app, which is the instance of our Azure functions, is gonna be working on Azure. So in order for us to understand which one to choose, we're gonna delve deep into the 3 of them. And the first one is consumption. And basically, consumption means that it's the pay-as-we-go model. So whenever we have any call or any event to our Azure function, the application will start, and then Azure will count the number of milliseconds that this application is running, and the amount of CPU and RAM that's actually utilizing, and then based on that, it will charge us. And whenever the function is not being in use, we're not being charged for it. But whenever it is in use, we are actually being charged on it. So it's a pay-as-we-go model, and it's by far the most default one, and it's the most popular one when you're starting working with Azure functions, because you don't really want to get charged, and you don't on stuff that's going to be sitting idle most of the time. The second one is premium, and premium is useful for running function app more continuously. And if you want to, for example, have more access to more CPU, have more memory options, for example, we want to specify our own VPN, we want to have create our own virtual network, for example, and have a bit more production-like environment, we can actually utilize the premium one. And basically, the premium one also provide a bit more flexibility when it comes to runtime. So, for example, with the consumption one, I think the limitation for an Azure function to run is up to 10 minutes. With the premium, we can actually push it to 15 minutes for a single function runtime, so it will not expire. So that will also provide much more. But the main benefit of it is actually having dedicated resources, because with a consumption plan, it will actually look for resources, and then it will automatically start initiating it. Although it will not take a lot of time, it's called something cold start, because it needs to find that resources, and then it needs to initiate itself and run. But with a premium plan, we'll automatically have these resources allocated for us, and it will be way quicker, way faster for it to be to run. And the last one is basically the most expensive option, and this is like the best option, but it's really expensive, is basically a dedicated one, which basically run an app service plan as if we are having an app service on Azure. If you don't know what an app service, it basically means that we buy or we rent these resources, like we rent, for example, a server with 3 gigabits of RAM or a certain number of CPU cores that we can actually utilize. And the dedicated one is basically fall into the same umbrella, and it will automatically handle the same scaling approach that an app service will have in order for us to utilize it. And this This way we don't have to wait for auto scaling to kick in, because it will automatically be allocated for us from within the app service plan. But again, the price difference between consumption and premium and dedicated are crazy, and I truly believe that no one really needs, if you're really implementing Azure Function as it should be, and if you don't really need the security compliance to have dedicated, I think a premium for production and consumption for testing, or even you can actually utilize consumption for production environment if you don't really care about cold start and you're having your application start. For example, if you're having a timer function that runs every 24 hours once, you don't really care about cold start, which means that a function will take few seconds to run. But for example, if you're having an online booking application or online e-commerce, and you wanna pay, you don't really want the user to wait 3-4 seconds until the function start and actually do its work, so you might utilize the premium one. But if you're running a reports every 24 hours, you might actually utilize the consumption, because it will save you money on the long run. You don't really care about the startup time. So again, depends on which case and which regulation you wanna regulatory requirement that you have. But I think consumption and premium are the most popular ones. Dedicated is only for certain cases. This will finalize the first part of Azure Functions. Please like, share and subscribe if you like this video. It will really help the channel. And please put all of your questions and clarifications in the comment down below. Have a great day.